We're going to create a frequency histogram. And what you see in front of you is everything we need in order to do that. We're going to create this frequency histogram by hand and not in the calculator. Generally, I'm a big believer in using the calculator to do almost everything in statistics. It saves time, it saves a lot of time, it increases accuracy, but somewhat ironically, graphing calculators are kind of tricky when you're trying to actually create graphs with them. And a frequency histogram is so easy to create by hand that I do not ever create histograms in the calculator. I only ever do it by hand. And we're going to see here how easy it is. This frequency histogram is based on data that I used in doing the presentation called Frequency Distribution Part 1. You can see that here. So if you were to watch that video, you would see where these data come from. And everything in this table down here is exactly the same as was presented in that video. So we start with a frequency table, which again could be called a frequency distribution. Frequency distribution and frequency table basically mean the same thing. And as we learned in that earlier presentation, there's really three ways that you can define your classes. You can define them in terms of class limits. You see here lower class limit and upper class limit. You can define them in terms of class midpoints. There you see the midpoints. Or you can define them in terms of boundaries, lower class boundary, upper class boundary. And in that previous presentation, we learned that the upper class boundary for the first class is the same as the lower class boundary for the second class. So there's a lot of repetition here. You can see, oops, I didn't want to do that. You can see we have 69.5 here and we have 69.5 here. We have 79.5 here, we have 79.5 here. Same with 89.5 and so on. So while it looks like we have a whole bunch of class boundaries here, many of them are repeated. So we really only have 1, 2, 3, 4, 5, 6, 7, 8 total class boundaries when you eliminate the duplication. And those 8 class boundaries are going to be the main thing that we use to set up our histogram. So you can draw this by hand. It's very simple. Just make the 2 lines for your histogram. The classes are going to go along the bottom or the x-axis, and all instructors want to see you name that axis. So you want to put in there female pulse rates. That's what we're dealing with here. You see the same thing up here, female pulse rates. You want to repeat that down here. And then the y-axis is always frequency. So these frequency numbers are going to come from this column right here, the frequency column. And these pulse rates are going to come from the class boundaries. So let's start with the x-axis. We're going to take this 59.5, which is our first class boundary, and it's going to go right here. So I'm just going to make this a little more readable. And there you see, our first class boundary is 59.5. Well, the next class boundary you can see is just going to be the 69.5. So we'll just do these one at a time. 69.5. The next class boundary is 79.5, so that's going to go here. And I'll just keep doing these. So there you see all of our class boundaries. And again, there are 8 numbers here, and they correspond exactly to these 8 numbers here that I have highlighted in yellow. On our y-axis, our frequency axis, we want to make sure that it's big enough, that the values there are big enough to include all of our frequencies. We can see here that the biggest frequency we have is 14. For the top of the y-axis, I like to use a number that's easily and repeatedly divisible by 2. It just makes it a little easier to create our markings along the y-axis. So I'm going to jump up to 16 here, and there's no right or wrong way to do this. I just think it's a little easier to do it this way. I'm going to put my top value as 16. So we have 16 there. Now if I go exactly halfway down my histogram, that value is going to be 8. And then if I split the difference between 8 and 16, this value here is going to be 12. Oh, and I forgot, I should have started. We've got 0 at the bottom here, and you generally want to have 0 as your starting point on the y-axis. And then here, if we split the difference between 0 and 8, we get 4. So there are all of our tick marks, I would call them, on the y or the frequency axis. And here are all our class boundaries. Well, now all we have to do is to plot these values in our graph. So if we start with the first class, and just notice, the lower class boundary of the first class is 59.5. That's here. The upper class boundary of the first class is 69.5. That's here, which means this column here is our first class. And the frequency of this column is 12. So I'm going to shade in that column. And so there you see, for our first class, the frequency is 12. For our second class, the frequency is 14. So I'm going to shade that in. Our third class, the frequency is 11, and that goes to here. I'm going to shade that in. The fourth class, the frequency is 1. So that's right there. The fifth class, the frequency is also 1. So that is right there. This class, the frequency is 0, so there is nothing to do. Just leave that blank. And this class, once again, the frequency is 1. So there you go. That is a complete frequency distribution. I'm going to go ahead and show you how easy it is to convert this to a relative frequency distribution in just a minute. I added this additional column on the table called relative frequency, and again, if you're not sure where those numbers came from, go back and look at the presentation called Frequency Distribution Part 1, and you'll see where these values came from. Well, it's very easy to plug these in over here on our basic frequency histogram. So let's do that. I'm going to get rid of the 16. This 12, if we look over here, 12 equals 0.3. That's the relative frequency of that value, 0.3. And by the way, if we're going to do relative frequencies, now we want to change the name of the y-axis to relative frequency. So I'm going to do that. And that created a problem with my spacing. So I'm going to change my approach to this. Okay, so I'm going to eliminate these absolute frequency numbers and put in relative frequencies that correspond to the height of these columns we have here. So this one here should be 0.35. So I'm going to insert a text box here. Okay, so for the second class, we see that the relative frequency is 0.35. So we're just going to put 0.35 right there. So that lines up with the top of that column. And our third class, The relative frequency is 0.275. That is right here. So I'm going to put in 0.275 for that. And then the only other one we need is this one down here for these three relative frequencies, which are all the same, 0.025, 0.025, 0.025. So that corresponds to these right here. So we are going to put in 0.025 there. Just noticed I never got rid of that 4, so that's now gone. So now for our relative frequency histogram, you'll notice we didn't have to change our shaded areas at all. They're exactly the same as for the frequency histogram. All we had to do was to change some things on the y-axis. We had to put in the word relative, and we had to put in these relative frequency values corresponding to each column. So that is how we go from a frequency histogram to a relative frequency histogram. It's all as simple as that. We didn't need to use the calculator. You can easily freehand this. Your instructor will be perfectly happy with that. It doesn't need to be accurate to scale. Just something close that's got the right values in for the axes. That will be fine. And that's the end of this presentation.